Okay, so let's start where we left off yesterday. Yesterday we discussed how KNN algorithm works. Okay, that means whenever we put our test data at that test data, it compute the distance with a pre-training point. Okay, and then sort the distances, and according to that, it picks what we specify how many neighbors you want to pick, and according to it makes a decision, either classification or regression that we have seen, right? And by default, sorry, means how the distance computation happens. We discussed that. You can see there are different ways distance can be calculated. It can be a Euclidean distance. Sorry, Euclidean distance. And how do we compute Euclidean distance? Using, suppose we have 2 points, x1 and y1. This is 1 point, and second point is suppose x2 and y2. So how do we compute Euclidean distance?
Square root of x2 minus
x2
x1
minus x1 whole square plus
y2 minus y1.
y2 minus y1 whole square. Sorry, y2 minus y1 whole square. Right? This is Euclidean distance. There are other ways of also measuring distance, right? Which you can select which distance metric you want to compute. Okay, there can be Manhattan distance. Okay, Manhattan distance. What is that? Same thing, just that mod of x2 minus x1 plus mod of y2 minus y1. Okay, this is what your Manhattan distance. This can be your Euclidean distance. This can be simply your Manhattan distance. And actually, all these distances have been derived from one formula known as Minkowski distance formula. Minkowski distance formula. Okay, so everything of this have been derived from Minkowski distance formula, right? And what is the formula of Minkowski? If you combine them, let me show you on the internet. That will be easier for you to understand. Okay, all these things have been derived from Minkowski formula. How? Let me come here. Just Google and type Minkowski distance formula. Yeah, it is better. Images. Yeah, that is fine. Let me pick it up. This is the perfect formula. If you observe this, everyone, this is the formula they have picked. Okay, and how they have selected, actually the point they have selected is one point is x and one point is y. That's the way they have picked. We have picked x1 y1 comma x2 y2. One point is x1 y1, second point is x2. This is what we have means we have taken this way. The one point is x1 comma y1, and other point is x2 comma y. Okay, the formula that you are seeing right now has been taking like that. One point is x1 comma x2, other point is y1 comma y2. Okay, this is the way they have written x1 comma x2, another point is y1 comma y2. Okay, so when we were calculating, we were using x2 minus x1, either square or mod. They are doing what? Simple, x1 minus y1 or y1 minus x1, doesn't matter here. Okay, ultimately what is going to happen, right? Simple, understand? So they have taken that points to be like this, x1 x2 to be the 2 points, and y1 comma y2 to be 2 points. Okay, now how they are mentioning, see, if we use this formula, then how do we write our Euclidean formula? Our Euclidean formula will become y1 or x1, y1 minus x1 whole square. It's something under root of something like this, y1 minus x1 whole square plus y2 minus x2 whole square. Okay, so when we are taking a square, does the order of y1 or x1 matters, everyone?
No,
it doesn't matter.
It
So means,
doesn't.
yeah, it doesn't matter. So same formula we can write this way as well, x1 minus y1 whole square plus x2 minus y2 whole square, right? This is one formula. And same formula if we write for the Manhattan distance, what will become? Mod of, again we are taking mod, then doesn't matter we do x1 minus y1 or y1 minus x1, barely matters. X1 minus y1 plus x2 minus y2. See, now this formulas can be combined in one particular formula. How? I can write this way. See, what is the first term? First term is what? X1 minus y1. Example in this, right? So I mention x1 minus y1 or xi minus yi. Take it this way. Xi minus yi means for first term this will become x1 minus y1. For second term it will become x2 minus y2. For third term it will become x3 minus y3. Now what? I want to do what? Understand? I take a mod of this example and power of this what? Understand? When it is a Manhattan distance, this power will become 1. When it is a Euclidean distance, this power will become 2. Okay. So I mentioned a term known as P. This P will be, understand, P will be 1 for Manhattan distance and P will be 2 for Euclidean distance. Right? Simple. I wrote this here. Okay. Then I did one thing. I put a summation sign here where I is equal to 1 to n, means how many data points are there. For example, we have in this case we have 2 points we are taking, so it will be from 1 to 2. In our case it will be 1 to 2. We are taking 2 points. Okay, means 2 points are there, and the values which are available here are only 2 points, 1 and 2. So x n minus minus we have mentioned. So x is equal to I is equal to 1 to 2. So if we expand this formula, everyone, only see this one, what this will become. If we put p is equal to 1, this formula will become mod of x1 minus y1 plus mod of x2 minus y2. Same, right? Everyone correct me if I'm wrong.
Yes, correct, sir.
Right? But if I put p is equal to 2, if I put p is equal to this formula will become what? Xi minus yi whole square, x1 minus y1 whole square plus x2 minus y2 whole square, right, everyone?
Yes, sir.
Right? Now see, if I take under root of this, so not under root of this, I make a power of this to be 1 by p. I make the complete formula, I make power of 1 by p. Now do one thing. Now try to put p is equal to 1 in the same formula. When I put power, this complete thing, I put the power to be 1 by p. So when I will put p 1 by p, that means 1 by 1 will be become what? 1 only, right? 1 by 1 will be what? 1, doesn't matter. Similarly, this p will become 1 here. So it will become mod of xi minus mod of yi to the power 1 only. So effectively your formula becomes only this. Summation I is equal to 1 to 2 mod of xi minus yi, right? When we put p is equal to 1, right, everyone? Only this formula will remain because power will become what? 1. Clear? Tell me, right or wrong?
Yes,
Correct.
sir.
Right, right. And when you will expand it, what it will become? It will become the same formula or not? The formula that we are seeing here,
Yes, it will become the
Yeah.
same.
right? But when I put p is equal to 2, what this formula will become?
Euclidean.
Yes, it will become a square and it will become 1 by 2, right? And 1 by 2 is what? Whole to the power 1 by 2 is what? Under root, right, everyone? Whole to the power 1 by 2 is what? Is nothing but under root. So what you are saying? First of all, outers is what? Under root. So you put under root there, see? Like this one. Whole to the power 1 by 2, that is 1 by p. You did that. Then inside that, what? This p will also become 2. This p will become 2 and this p will become 2. Both will p will become 2. So this will become what? xi minus yi whole square. That means for I is equal to 1, it will become x1 minus y1 whole square, like this. Summation sign. That means plus x2 minus y2 whole square, right, everyone?
Yes, sir.
And this is nothing but your Minkowski formula, the formula that you are seeing. So both the Manhattan distance formula and Euclidean distance formula has been derived from which formula? Root causes Minkowski distance formula. Okay, so root is this one, Minkowski distance. So if you see in, we will see in our algorithm, we will mention that Minkowski. Okay, so you should understand you can change the value of p as per your requirement. You want to make it Manhattan, then make the p is equal to 1. You want to make it Euclidean, you can make p is equal to 2. Fine. There is one more formula. Okay, this is for numeric. If you have a numeric columns available, okay, for that purpose, this Minkowski formula or the Manhattan formula or the Euclidean distance formula will work. But there is one more distance formula. Let me click on the same. Yeah. What is that? That is Hamming distance. Okay, what it does. Suppose you have text columns. Okay, column 1 and column 2, in which I have mentioned, or one more thing is there, 3. Here it is A, B, C. Okay, here it is A, B. Okay, here it is suppose B, C, D. Here it is C, A, B. Something like these are your training points, right? And some test point is given to you. Test point will be very much similar to these only. So something is given like A, B, and A. Something this is given to you. Okay, and you are asked, please compute the distance of this test point with each of these test points. How much is the distance? right? So now it is a text. Okay. So of course my Euclidean distance formula, Manhattan distance formula, or Minkowski distance formula will not work. In such cases, Hamming distance will come into the picture. And how will we compute? We'll take our A, test data points B and A. We will take first data point. What is that? And compute distance with this A, B, and C. And we will compute distance how? Compare one with one. There is a match. Yes, distance is 0. Compare B with B. Match. Distance is 0. Compare A with C. Yes, there is no match. Distance is 1. Now sum of these. So total distance with this is 1. Done. Move ahead. A, B, A. Compute distance of A, B, A with this A, A, B. A, A, B. Compare A with A. Match. Distance is 0. B with A. No match. Distance is 1. A with B. No match. Distance is 1. So distance is, cumulative distance is now 2. Move ahead. Again, take A, B, A. Third point. B, C, D. Compare. A with B, no match. Distance is 1. B with C, no match. Distance is 1. A with D, no match. Distance is 1. Cumulative distance is 3. Now last. A, B, A with C, A, B. Compare. A with C, no match. Distance is 1.
1,
B with A, no match. Distance
1,
is 1. A with B, no match. Distance is
1,
1. So distance is what?
3.
3, right? So this is how we can compute distance if we have a text columns with the help of Hamming distance. Okay, so if you have a text column and you want to compare the distance, in such cases, your Euclidean formula, your Minkowski formula, or your Hamming distance formula or Manhattan distance formula will not work. The distance formula that will be used will be what? Hamming distance. Okay, normally when you are designing a machine learning algorithm, it will not require. This is required for those people who work in industry or do the research. Because whatever you do the algorithm, actually you have to justify that by the help of calculation. Okay, same result I'm getting with the help of calculation. For those people, it is important. But as a you're just designing, you're doing the coding, then it is fine, no problem of you not even bother about this. But I think you should know all these things. Okay, now let's come to one task. Okay, it should be okay now. So I'm coming to not here. Yes, here. Where is Jupyter? On here. Okay. So let me do one thing. Let me read a data set. Okay. df is equal to pd dot read underscore csv. And I think in D drive, I'm having the data. So D colon slash, let me pick, it is there or not. I'm not sure. Yeah, it is there. Let me execute this. Okay, it has been read. And let me read its first 5 rows. Let me see how the data look like. So I'm starting my EDA. Okay, so I will do the basic EDA and I expect rest of the EDA will be completed by you. Okay, I'll do all the necessary steps which are required for machine learning algorithm to do the work, but I expect you devote at least 4 hours, 5 hours, okay, on analyzing one data so that you can improve your model. Because you know how to plot everything, how to find out the relationship between two columns, what are your findings and everything. You know that everything very well now. So expect you will be able to do that. Okay, so let me
So,
start. Yeah.
how do we get these data sets then?
Sir, I'll give you. Actually, there are various websites. This is a very, very good website. If you go onto the Google and just type, there are two very, very famous websites. One is your UCI machine learning repository. This one. Okay. So you have huge number of data sets available here. Huge number. Very, very huge. Okay. So you can book from that. It is available here. See, different data sets are there. Heart disease, wine, several data sets are there. Another way of finding the data sets is Kaggle. Okay, on this data set, for example, click on data sets. Now, come on. Okay, you will find lots of data sets which are available for you. Can you see, sir?
So, yes, sir.
Okay, so those two websites are very famous. You can find from this. Very huge number of data sets are there. As per your requirement, whatever you are working, just pick it up and experiment. Normally, in real time, you will not using this Kaggle data set. You will be working on your industry data or your college data or something.
Right.
Or whatever data will be. This is just for the practice purpose. Okay, and I will give you these data sets. Don't worry. Whatever I'm using, I'll give you.
Right.
Yeah, I'll
Sir.
give you. Okay. So let me use this. So I have also downloaded this from somewhere way back, but I don't remember when I did that. But let's explore the data. Okay. df dot head. Okay, so I have some columns known as item identifier, okay, item weight, item fat content, awesome, item visibility, item type, dairy, soft drinks, meat, fruits and vegetable, households, okay. And then we have item type, which is item type. We already seen dairy, soft drinks and meats, fruits and vegetables, households, okay. And item MRP is given, outlet identifier is given, outlet establishment year is given, outlet size is given, okay, and outlet location type is given, outlet super type is given, super type, market type 1, type 2, type 3, and item outlet sales is given, okay. So in this, first of all, my requirement is to predict the item outlet sales. This is the requirement. Means we have to build our machine learning model which can predict item outlet sales. Okay, which can predict item outlet sales. So which kind of problem it is, everyone? Classification or regression?
The regression.
Yes, perfect. Because we are not classifying, we are just predicting some continuous numeric output. Okay, so important thing, it's a regression problem. It's a regression problem. Okay, and always analyze your data properly. The very, very important thing that is required here. See, we have some columns here known as FDA, DRC, FDN. Do you know what is this? No. How will you come to know? Of course, we are working on a random data. We have not used this data set ever. Means even we have used, we are not working in the same industry where this data set belongs. So these have some particular thing available where your domain knowledge comes into the picture now. Here comes your domain knowledge. That's why industry hires experienced people, right? Why? Only reason is that they do have experience in their domain, which a fresher can never have. That is the main problem. They get hired the experienced people because the experienced people understand what this coding means. So there is some column whose information I don't know. What is this? One big problem, but we'll see that. Don't worry. I'll come to that. Okay. Now come here. Item weight is fine. The weight is given. Fat content is given, is clear. Visibility means how popular it is. Item type is mentioned, dairy, soft drinks, okay, and meat, fruits and vegetables, okay, and households are given, okay. MRP is given. Outlet identifier, some they are given some identity to the outlets. That information is there. When it was established, the corresponding year is given. Size is also clear. That's not a problem, okay. But this is the, how can we identify what this tier 1, tier 2, tier 3 means? Until we know our domain knowledge. Okay, until I know what is a tier 1, tier 2, tier 3, how can I code them? Because remember, ultimately, we have to convert every data into numeric data. We will not use directly this outlet size, medium, this item type, dairy, or this supermarket type 1, or something, something, something. Okay. No, of course, we have to convert all this text data into numeric data. But there are certain rules how you should convert. Okay, let me discuss first that. What are the rules for the same? Okay, so let me come here. Our machine learning model will understand only what? So understand numeric data. That is very important. It will understand only and only numeric data. So we may have two kind of text data. One can be nominal data. Okay, and second can be ordinal data. Okay, so in our data set, we may have two kind of data. That one can be your nominal and second can be your ordinal. Okay, nominal means no numeric weightage. No numeric weightage. And ordinal means yes, numeric weightage is there for every item. Example, see, if there is a column known as gender, okay, in which something is mentioned as male and female. Okay, can you tell me, everyone? I have to convert into the numeric column. So is there any numeric weightage to the male or a female, or both are equal? Is there any numeric weightage of the male? Can you differentiate male is superior or female is superior? Can you do that?
Both are equal.
Yes, both are equal, right? There is no numeric weightage. Such columns are what? Nominal columns, or having nominal data. They don't have any numeric weightage. Both are equal. You can say male is superior or female is superior. So you have to give them equal consideration, right? But see, Here you have a column known as suppose size. Example, what kind of size? Let me mention. Size of shirt, in which you are mentioning triple XL, double XL, L, medium, small. Are they same or they have some numeric weightage, everyone?
They will have numerical weightage.
Yes, they have a numeric weightage. Such kind of data is what? Your ordinal data, right? Such kind of data is you're having ordinal data. So for converting your nominal data, there are different rules, and converting your ordinal data, there is a different rules. That's why I said, whenever you see a text column, you should have the knowledge of the data set properly, what this represents. If you don't have a knowledge of that, understand how will you code them? How will you convert them? Okay, so for nominal data, they are different route, but in ordinal data, certainly you have to assign them weights, and how the weight has to be designed as per their weightage. Which is largest, everyone? S, M, L, double XL or triple XL? Which is largest?
I think triple XL.
Yes, a triple XL. So it should be given the more weightage, means something like that. I should be assigned a numeric weightage 1, medium should be 2, small should be 1, medium should be 2, large should be 3, double XL should be 4, and triple XL should be 5. Now it has more weightage. It's ordinal. So when I will convert ordinal data, so I will assign them according to the weight. I will assign them according to the weight, right? Because weight is important for me now. Similarly, you are doing some crime investigation. Okay, crime investigation in which there is a record of every human. Okay, their education. Okay, somebody is PhD. Okay, somebody is masters. Somebody is graduate. Somebody is only 12th pass. Somebody is only 10th pass. Tell me, is there any order or not? Everyone, tell me.
Yes, there is order.
Yes, there is order. This is what kind of data again?
Ordinal.
Ordinal. So again, we have to do the weightage. The smallest one has a smaller weight. 1, 2, 3, 4, 5. Similarly, you have suppose item outlet size option is there, right? So it is mentioned like large, medium, small. So is there any order or they're same? Everyone, again, you can answer. Yes, it is an ordinal. So again, what kind of numeric weightage we have to give? Example, this to 1, this to 2, this to 3. So higher weightage should be given, which is at the highest level. Okay, the smallest weightage should be given, which is at the smallest level. This is how we deal with the ordinal data. Okay, so we'll convert them numeric data, but how we will convert them? More weightage to the thing which is at the top order, right? And small weight to the one which is at the lowest order. Clear, everyone? How we will deal with the ordinal data?
Yes, sir.
Okay, now see how to deal with the nominal data. Let's come to that now. But don't worry, this will happen with the help of code very, very easily, but you should know how basically things happen under the hood. That is very important. Okay, let me come here. Now come to nominal data. Okay, and with the help of nominal data, means how do we deal with the nominal data? Okay, we do one process known as one hot encoding. One hot encoding thing. What is one hot encoding? Understand? Suppose there is a column known as gender. Okay, in which 3 entities are there. There are several rows in this particular column, several rows. So in first row, there is male. In second row also there is male. Third row, there is female. Okay. Fourth row, there is a transgender. Okay. In fifth row, there is again female. Okay. In sixth row, there is male again, something like this. So in one hot encoding, what will happen? Understand? How many distinct values are there in this gender? You will count those. How many distinct values? 1, 2, and 3. 3 distinct values are there. So 3 new columns will be created for you. Those will be called as dummy variables. Okay, 3 new columns will be created for you. Those will be known as dummy variables. Understand? Those will be known as dummy variables. So one column will be known as male column. One column will be known as female column. And one column will be known as transgender column. So 3 new dummy variables will be created. Right? And how it will be coded? Understand? Whenever there is a male, see, we saw first row. What is this row? This row is corresponding to male. So wherever there is male, I will mark it as 1. Rest I will mark as 0. So in any one row, only one of these 3 variables will be 1. In any one row, only one of these variables will be 1. That's why one hot encoding is this. Male, again male. So this will be 1. These two will be 0. This is what female. So female will be 1. Rest of them will be 0. Transgender. So transgender will be 1. Rest of them will be 0. Female again. So female will be 1. Rest of them will be 0. Male, only male should be 1. Rest of them will be 0. So when we do such kind of encoding, this is known as your one hot encoding. That's why it is important to understand your data set. Okay, in this particular text column, we have an ordinal data or we have a nominal data, because the type of coding will change. Although your machine learning model will be built, of course, if you do one hot encoding, even with the ordinal data, it will work. But of course, your result will not be that proper. Because machine learning is not going to say, okay, you are doing wrong thing, you have to do this encoding. No, it doesn't understand that. Whatever you will do, it will accept. So whether you do one hot encoding to your nominal data, or you do your coding as per the weight for the nominal data, even it doesn't understand. You give it, it will take that. Doesn't matter. Means if I have a ordinal data example, okay, and for ordinal data, you use what? You use one hot encoding. Your machine learning model is not going to complain. Just that it will build on the basis of whatever you have given. But of course, your performance will not that be good. Okay, that's why identifying your columns properly is very, very important. And that's where the domain knowledge comes into the picture. Okay, don't worry, you have to do very, very simple. We have a function for the same pd.getDummies function. We'll see that pandas, we have an option known as pd.getDummies, and we will pass our data flow. Automatically, it will pick the text column and create this dummy variables. Manually, we don't have to do this. But you should know how internally it works. Yeah, everyone. So I think if somebody asks you in the interviews, how do we deal with the text columns? You can immediately answer, say there are 2 ways, depending upon that text column, what kind of data we are having. If we are having nominal data, we will use one hot encoding. Okay, and if it is ordinal data, we will assign them the weight according to their weightage, according to which order they are, as I mentioned, everyone. Clear? Please tell me.
Sir,
Yes, yes.
Yes, this one hot encoding is okay. But every time we are getting male one, but how will you distinguish between the male entry and female entry?
This column, see, from the columns it will identify. These values are 0, means they have what weightage you have given them. 0, 0. That means yeah,
three values it has to give. Three bit encoding, as I can say.
Yes, right. 3 bits will be passed. You can say 3. This column information will be passed. This column information will be passed. This column information will be passed. And my machine learning model will automatically understand, okay, these 2 are 0, means definitely this data is corresponding to what? This male attribute.
Okay.
Correct.
That means
similarly,
just like binary encoding type.
But in binary, multiple digits can be same at the, remember, 1 can be at the same time. In binary, right, multiple digits can be 1, but in this, never multiple digits can become 1.
Okay.
Okay, only one hot means at one row, only one attribute will be 1. Only one attribute will be 1.
But depending upon the distinct entries, the bits will change. The
Yes,
number of columns will change.
Yes. Suppose you have a 10 distinct values, so 10 distinct columns you will be created.
And all those 10 values will be passed as an encoding.
Yes, as an encoding.
Okay.
Yeah, all 10. Yeah, but in ordinal, we don't have to do that. Only one column we will assign just the weight. So one column will work in that case, in ordinal case. Clear? Please tell me.
Yes, sir.
Okay, fine. So let me move ahead now. Okay. So we understood that. Okay. So we'll come to that. No issue. Come here. Back again. Okay. So that's important. We have to understand everything very, very properly. Okay. What is required for me? What is not required for me? Before that, let me move ahead. It was important to understand the text column and weightage of what kind of text columns you may have. Okay. And remember one more thing. In your machine learning model, anytime you find a column which is unique for every row, means in every row you have a different value. Okay, in every row you have a different value. For example, here we have some value which is only for this row. only for this row, only for this row, only for this row, only for this row means suppose in data set I have 1,000 rows, and in this particular column I have 1,000 distinct values. Okay, then trust me, this column is not for use. No point. No point. It is going to help you out a lot. Okay, so never keep that in your machine learning model. It will not going to help you out, not at all, because it is distinct for everyone. No? So how it can help you out in the predictive machine learning model? Not at all. So if in a machine learning model there is any column which is having distinct value in every row, okay, distinct value in every row, then you can drop that column without blindly drop this. No point of taking into the machine learning model. Clear? Because it is distinct for every row. So how can it help you out in the prediction? As simple as that. When it is simple, how do we learn machine learning model? We learn from the history. But that model, that particular column is never helping you out. It is whenever row is changing, it is changing itself. Whenever row is changing, it is changing itself. So in every row, we have a distinct value. So how can it help you out in building the machine learning model? So no point of taking as such column which are distinct in every row. So you can drop those columns. Don't take for building machine learning model, because it is not going to help you out at any cost. We need to find some pattern, right? So when it is like this, it is changing every row. So can you find out any pattern? No, of course not. But in every row, that value is changing. Every row that value is changing. You will never find out any pattern. Okay, so we don't take that kind of column in building machine learning models. Clear, everyone?
Yes, sir.
Okay, remember that. Okay, so we will not keep that in mind, and that's why exploration of every column become important, which you think it is confusing. Okay, it may be what I don't know what information it may be unique, because looking at 5 rows you cannot say anything. You can just analyze, okay, how many columns are there, what kind of data types they are having. Let me change the shape first of all. We still not know how many rows are there in this data set, right? So what do we use? We have a method known as, attribute known as df.shape. There are 8,523 rows in this particular data set. Okay, 8,523 rows in this data set, and 12 columns are there, out of which one column is your output column known as which is what? Your item outlet sales. Okay, this is important for you. Okay, so we can say 11 columns are input variables. Okay, and one column, which is what? Item outlet sales is output variable or target. And what we have to do, we have to find out relationship between this one column and rest of the 11 columns. Okay, we have to find out a relationship between, means predict a pattern between this and these 11 columns. So output versus all the input. So my output is a function of all the input columns. Fine, but that analysis you have to do. How much is the dependence? Is it constant? Means it is not impacting. How can we do? When we plot every item outlet sales with everything others, then only will come some information. Then only we will be analyzing. That's why I say devote at least 4 to 5 hours properly, analyze every factor. How it is it important? It may be possible there is some column which is not even impacting this, means something like this. If you observe something, see, there is a column, suppose X. Okay, this is my item outlet sales. And whenever X is changing, your item outlet sales is constant. It is not changing ever. Tell me, is there any impact of X on item outlet sales?
No impact.
No impact. So should we keep this column? Of course not. It is not impacting my sales. So why will I keep it in building my machine learning model? Again, getting the point, everyone?
Sir. Yes, sir.
Right,
Yes, sir.
right. So please, that's why I say analyze. Your simple analytical skills should be strong. That's it. By common sense, you can understand. Okay. Earlier, what was happening when we have a distinct value in every row? Of course, every time pattern is changing. Every time the row is changing, the value is changing. So there you will never find a pattern. So no point of picking that. Whenever it is changing, right? Similarly, here what is happening? Your column is changing. But your item outlet sales has no impact. It is remaining constant. That means it has no impact on this. There is no point in keeping this column now. No point. That's why your analysis becomes very important. That's why it is EDA is very. I told you, 70%, 70 to 75% of the time, your data scientist or machine learning engineer spends on EDA only. Building machine learning model, you will see barely take 5 minutes. But before that, you have to analyze your data properly by using all the visualization methods, your pandas method, group by method, analysis method. How can we analyze the data? Only after that you can build a good machine learning model, right? So let me move ahead now. Okay, so we come across, we have how many columns are there? 12 columns, out of which one column is item outlet sales and rest are your input columns. Okay, let me check their data types, what kind of data they are having. Okay, so just type df.info method. Okay, so it is telling me what, see, item identifier is an object, that is a text column. Okay, you will see other than float and integer, whatever you will see. Okay, or date is even not, there is no date column. So wherever you will find an object, okay, that is a text column. Object, 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 object. And see properly here, there are in total 8,523 rows. But see, in every column, the information same is not mentioned about non-null values. Okay, it has 8,523, but it does not have. Observe this. Okay, it has 7,060 non-null, means rest of the values are missing values here. Similarly, come here, fine. See here also. What is this? 6,113 are non-null values and rest are the missing values. Okay, and how can we verify them? Now let me come here. Okay, I'm going to type df dot is null. Okay, dot sum. It will tell me in every particular column how many missing values are there. It's clearly showing me. We have missing values in item weight column and same thing is shown here. See? Because it does not have all the rows. We have missing values in this particular column, item outlet size. Same number of rows are not there. So immediately you come to know, okay, there are missing values, right? And we can verify same thing with the help of our heat map as well. So let me import Cbon as SNS. Okay, SNS dot heat map and pass this inside. What happened? SNS dot heat map. Fine. Let me just put it this. Yeah. Can you see everyone? Only these lines you are seeing in which are available in which columns? Your item weight and outlet size. It's mentioning from 0 till all the rows which are available, which are missing. Can you observe everyone?
Yes, sir.
Right. So now earlier, remember we saw the graph in which everything was pinkish only because there were no missing values. Now those missing values are visible here. But better this is better. Okay, so we have to deal with this missing values. So how can we deal with these missing values? Okay, for that purpose, actually what I've intentionally kept some data for you. Okay, that is what data set. In this data set, I have 3 rows. Okay, there are 3 columns, name, age, and gender, and we have just 3 rows, 0, 1, and 2. In this, name column is A, age is 10, gender is male. Second row, name is B, age is 12, but there is a missing value, NAN, which you can see here. Okay. Similarly, also here also you will see an NAN. Suppose I want to show you something. How many rows we have seen? This one. Okay. Let me do one thing. I think it should be visible here. Yes. Can you see here, everyone? Here also NAN is there.
Yes, sir.
Okay. In which column it is? Can you see? Outlet size only. And in outlet size, we have missing values. See? Right? So we have missing values in item weight and outlet size. So these are visible here. NAN. Same thing it appears here. NAN. And same thing is you are seeing here. So these are what your missing values, which are not there. So how can we deal with this missing value? See, there are 2 ways to deal with the missing values. There are 2 ways. Number one, drop the rows which are having missing values. First way. Second, impute the values where data is missing. Okay, known as imputation. Okay, two ways are there. Either we can drop the rows which are having missing values, or we can impute the values where data is missing. It depends. It depends what we should do. Okay, suppose in your data set you have 1000 rows. Okay, out of this 1000 rows, there is a missing value only in one particular column. Let's say only in one particular column, and only 3 are the missing values. Only 3 missing values are there, of course. Then what will happen? Understand? Even you drop 3 rows. So how many rows are still remaining? 999.
997.
No problem. Design your machine learning model, drop them. Because 3 R rows are not a huge number. So they are not going to impact a big thing from you. Acceptable. So you can drop. Okay. But suppose out of 1000, example, there are 400 missing values. Now, when you drop them, how many rows will be remaining, everyone?
600.
So already 60%, 40% data is gone. In such cases, what is better? Go for
Imputation.
imputation. Okay, so always see what is your requirement. Accordingly act upon. There is no universal rule actually. There is no universal rule in the machine learning algorithm. You have to do this, then do this. Your common sense, your requirement will come into the picture. Okay, your understanding of the subject will come into the picture. How you are understanding the problem scenario, that will come into the picture. Right? Even sometime dropping these 3 rows may be dangerous for you. Even these 3 rows, because suppose you are working in a classification problem, and in those classification problem, only these 3 rows. Suppose in that one, 997 rows belong to one class, and 3 rows belong to second class. And in one particular column, you have missing values only in those 3 rows. So you will drop them. Then second class will be completely dropped. Getting my point, everyone?
Yes, sir.
Right? Then no point of creating your machine learning model even. Right? So that's why always understand the requirement, see what is my data model, and then accordingly act upon. Okay, so there is no universal rule. You have to do this, you have to do this. Okay, now let's see how to drop the columns. Okay, how to drop the rows. Both things we can drop. We want to drop, we can drop the rows, and we want to drop the column, then we can drop the column. Very, very simple way. See, if I mention df dot drop any, just this, nothing else. Okay, drop any, it will drop all the rows. Okay, all the rows which are having missing values. That means if I execute this row will be gone and this row will be gone. Only thing will be left is 8 and M. Execute this. Oh, sorry, what I did a mistake again, because I didn't want to. Okay, let me do from the scratch again. Let me read it from this, from this, from this. Awesome. And then this, and then this. Yeah, fine. Can you see everyone? Please observe. How many rows are left?
Only one.
Only one, because these 2 rows had what? Missing values. That's the main problem, right? So all the rows which will having missing values will be dropped. Okay, but suppose what you want, you want to drop the column. But normally we don't drop the column for the missing values, we drop rows only. But suppose in case you want to drop those columns which are having missing values. So which column will be dropped? Name will be dropped and gender column will be dropped. So instead of that, my DF is original the way it is, because it is not happened in place right now. Okay, if we go here, see there is an argument. If we go come, yeah, see in place. Okay, there's a column known as in place, which is what? False. So it is not impacting your original data frame. If you want original data frame to impact, just make it true, then it will impact that. Okay, so that's why the original data frame is the way it is. Now I'm mentioning df dot drop any. Okay,
Since
but I
you have to change.
mention axis is equal to
Yeah.
1. Okay, axis is equal to 1. I change the axis. Okay, so by default axis is 0, so row was dropping. Now I need to drop the column, so I will mention axis is equal to 1. So all the column which are having missing values will be gone. So name will be gone, gender will be gone. Only thing that will be left out will be age. Can you check, everyone?
Yes, sir.
Right? But again, your original column is the way it is. Original data frame is the way it is, because I didn't did in place. Okay, so normally dropping your column for the missing value is not recommended. What is recommended? To drop the rows. That is better. Okay, because your column may be important for you. So not recommended. Now see, also we can do one thing, df dot drop any. I can control which row to be dropped, which row not to be dropped, depending upon the condition. Means I put a condition, suppose when a row will not be dropped. When a row will not be dropped, for that is a parameter known as thresh. Thresh, yes, like this. Okay, suppose I mention here 2. So what it tells, okay, I will not drop a row. I will not drop a row if in that particular row there are at least 2 non-NaN values. I repeat, 2 non-NaN values. This not, I am repeating once again. I will not drop the row if that row is having minimum two non-NaN values. So tell me, how many non-NaN values are there, everyone? Non-NaNs in this case, non-NaN.
1.
Only 1. So will it be dropped or will it be kept?
It
It
will be
will be
dropped.
dropped. Yes, it will be dropped. Now come here, everyone. How many non-NaN values we are having?
2.
2, right? So it will be kept,
2.
right? How many non-NaN values we are having in this case? 3.
3.
Right? So it will be kept. So minimum 2 non-NaN values should be there. So we will be having only 2 rows if I execute this. Check, everyone.
Yes, sir.
Right? If I mention here 3, let me come back again. Here, here itself, df. Okay. If I mention here 3 in thresh, can you guess what will be remaining, everyone?
All 3 will be remaining.
No. Please see properly. What is the rule? How many
Minimum
non-NaN?
3.
Minimum 3 should be there
non-NaN.
for not to be dropped. Yes. So anyone which will be remaining?
So minimum 3 should be there, means only one first row.
Only first row. Yes, only first row. Because
Only
it is
first row.
having 3 non-NaN values. Okay. See. Right? So you can set a role. When you want to drop the rows, you can control which rows to be dropped, which rows not to be dropped by using threshold. Clear, everyone?
Yes, sir.
Okay, now move ahead. This was about dropping the rows. Now coming about the imputation. Okay, how can we impute the values? So let me come again with my df. What is my df? Again back. Okay. So for imputation, what we can do, we can mention df dot fill any like this. Understand, everyone? Df dot fill any, or I can directly pick up a column and do something like this. See, df. What is the first column name? Name. Okay. Dot. I can do both the things. I'll show you that you can do both the things. Df name dot. Okay. Fill any. Okay. Value equal to, suppose I mention here my name. So in this particular column, wherever there will be NaN values, what will be substituted? Praveer will be substituted. Let me execute this. Can you check, everyone? AB and Praveer.
Yes.
Observe this, right? So earlier it was here what? NaN. Now what it is there? Praveer. Okay. Let me check my original data frame. It is the way it is because we have not done in place. I think, let me check, is there an option of in place? It is there, right?
Yes.
Okay, but we have not done that. Okay, or we can do one thing directly. See, df dot fill any. I'm applying, earlier I applied on a column, right? Individual column. Now I'm applying on a entire data frame, fill any. Value equals to Praveer. So wherever in entire data frame, whatever your data frame is, wherever NaN will be there, there Praveer will be substituted. Check, everyone.
Yes.
Yeah, so both way you can use, but normally we don't use as a complete data frame. We use as a individual column because imputation has some rules. Imputation also has some rules. What value to substitute? Again, there are some rules. Like for the text data, there were some rules. For imputation, also there are some rules. What are the rules? See, if you are having continuous numeric data or a floating point data, okay, you have a continuous data, then we substitute the missing values by the mean of the column. Okay, by the mean of the column.
Okay.
Right? If it is a continuous, if it is discrete, okay, then we substitute by median of the data. Median means 50 percentile. We substitute by the median. But if it is having example text data, then what we substitute? We substitute by mode of the data. Mode means the item which is occurring most time in a column. Sorry. Mode. M-O-D-E. For example, in a column, we have male, we have male, we have male, we have female, again we have male, we have female. Which is occurring more, everyone? Male or female?
Male.
Right?
Male.
So mode will be male. Clear? So three things are there depending upon what kind of data is available in the column. If it is a continuous data, then you will substitute by the mean. If it is a discrete data, you will substitute by median. If it is a text data, you substitute by mode.
Mode.
Right? And normally, understand everyone, again here your domain knowledge come into the picture. Without even calculation, you can put it on. Depending upon your domain expertise. Not mandatory again, remember, not mandatory. That you will calculate the median, then you will substitute. You know, you have an idea, okay, discrete value. This is the normal discrete value most of the time. You can directly put, if you have a domain knowledge. I repeat once again, same thing. Right, directly you can do that. So domain knowledge comes into the picture here this way. Okay, so this is the rule: continuous or discrete and whatever you want to do. So how can we substitute? Let me come here. Clear all drawings. Okay. So first data is which kind, everyone? Can you observe?
Text.
Text column. So what should I do?
Mode. Replace by mode.
Mode, right? But I think what name we have used here? Come here. Remove. What thing we have used here? Come. Everything is unique here. If you come here, A and B, right? Makes no sense. But let me tell you, we will implement same thing in our original data set. Okay. So let me come there now. You get a basic idea how to fill any. Now let me come to our original data frame, which we were using. So let me come here, execute this, again execute this. Come on. Now come here again, ship, done. Now come here, run, again come here. Right now we will do something. Okay. Done. Awesome. Now come here, everyone. Now see, in this column we have what? Missing values. What is this? Weight. Right? Now check. What is the data type of the weight, everyone? Check, please. What is this?
This is continuous.
Float. Yes. Float means continuous. Sorry. Float means continuous. So what we should do?
Or average.
Sorry. Yes, mean value. You can
Replace
find
by
out the, yes, find the mean value. So what I will do? I will calculate the mean value. How? I'm coming here. df. What is the name of the column? I think item weight. Okay. Item underscore starting from capital W. Okay. Yeah, item weight dot mean. Let me check what is the value of the mean. 12.57. Right. Can you check, everyone? And let me save it in a variable. Suppose mean. Done. So this is my mean value which is available. Okay. Now what I will use? I will come here and mention here df same item underscore weight dot, which method, everyone? Fill any. Right? In this column, fill any. What then? Value.
mean.
Value
Equal
equals to what? Mean.
Mean.
Right? And I want this thing to happen in place. I will mention in place equals to true. Okay, let me execute this. Done. And now let me come across and again experiment, again execute this equation, right? Earlier we have missing values, 1463 missing values in the item weight. Now let me pick it up. Execute this. Can you check now, everyone? How many missing values are there?
0.
Gone. Right? Now let me come to item outlet size. This one. Now let's check which kind of data it is having. Come on. It's an object, right, everyone? It's an object, that is text. So what will work? Mode will work.
We need to,
right? Yes, mode will work, right? So see the item outlet size. Where is the outlet size? This is the one, medium something medium high, right? We can observe here. So we need to find the mode. So how do we find the mode of this column? I'll come here. Okay, I will mention df, and in the square bracket, I will mention outlet size. Okay, dot mode. Okay, I want to find out its mode. Okay, simple as that. Let me execute this. So mode is medium. Medium is coming more. Okay, so it is coming. It is not coming directly. So let me put square bracket and 0. And now it is fine. And now let me save it. Okay. In suppose mode equal to this. Okay. Now how will we substitute everyone? Same column dot fill NA.
Fill NA.
Value is equal
Value
to
is equal to
mode.
mode.
Yes. And
And
in
in
place
place is
equals
equal
to
to true.
right. Done. And now let me check. Earlier we were having 2410 missing values. Now let me execute. Not this. df dot. Let me type directly. Dot is null dot sum. Check everyone. There is no missing value available anywhere.
Good.
Clear everyone?
Yes, sir.
Okay. That's why if you build a machine learning model, it will take time. It will take time, a decent amount of time. Okay. So I'll expect you one thing, everyone. If you can spend time, we'll stop for today. Do one thing, please. Take this data set with me. I'll share with you. Okay. Please analyze it. Please analyze using the visuals, univariate analysis, bivariate analysis, everything you should do. And tell me what finding you achieved yesterday on Monday. Is it fine, everyone? We have Sunday tomorrow, so you can experiment that.
Yes, sir.
Okay. Varun and Hardik and others, please.
Yes, sir.
Okay. So I expect you people. Any doubt in this today's class? Just tell me. Even single.
No doubt. But please share this source file, sir.
Sure, sure. Let me share
That
directly.
we'll
Just a
come to
second.
know about the commands.
Yeah. Just a second. Just a second. Okay. So let me first of all share with you. I think your is May. May. Where is May? Come on. May ML train. Yeah, fine. Okay, just a second. Let me first of all share with you that dataset file. D drive, Big Mart. Yeah, this is the one. Okay, this I have just shared, and let me share this file as well, Jupyter Notebook, with you. Actually, for average, how can you find out? See, text for the text, you can find me. Varun, tell me. Let me pick any text. Okay, any text column. Suppose this text column, item type. Okay, let me show you something. DF. What is the column name? Suppose fat content. I think that is the text item fat content. Okay, let me find out the mean. See what I'm getting? Can you see? Could not convert string to float. Yeah, can you see, Varun? The error we are getting here, right? Because we cannot find the average of the text. Simple as logic is that, right? Okay. So this files are you talking about to share? This one that we are using?
Yes, sir. Yes, sir.
Oh, I'm sharing right now currently. Just a second in front of you. Otherwise, I know I will forget later on. Just save it. Let me close this. Although several work has to be done on the same file. Okay, we have just done the one step, only missing values, but actually everything is important step by step. We'll also do that coding as well. We have not done the text encoding yet. Okay, that thing
Yes,
needs
sir.
to be done. We have to done scaling as well. Okay, because it's a distance based algorithm, so we have to done scaling as well. So several things are remaining. It will take at least 1 more hour to complete it. At least 1 more hour. Because building machine learning model is very easy. Main thing is this. Okay, let me quit this and let me go here. Oh, come on. This PC, C, users, Dell, and I think the name is KNN. Yeah, this is one. Fine, perfect. So go here, attach. C, users, Dell, and KNN. Yes, this one. Done, sir. Fine. So both things I have shared with you. Okay, so please everyone, just bit experiment and do as much analysis as you can do. Okay, we'll meet on Monday.
Sir, I wanted to ask one question.
Yeah,